Everything around us is made up of atoms. Some atoms keep to themselves, but many of them combine with other atoms to form molecules. All atoms that exist anywhere in the universe are represented in the periodic table of elements in an organized manner. According to their general properties, they may be divided into two major groups: metals and nonmetals. Metals possess some specific characteristics, such as being shiny and being good conductors of electricity and heat. Some of them, such as gold, silver, and platinum, are encountered in nature in their free state, that is, not combined with other atoms. Most metals, however, are chemically active and form stable compounds. An example of a spontaneous reaction involving a metal occurs when a piece of iron is exposed to the air. After a few days, we discovered that the surface is covered with a reddish layer of iron oxide, rust, formed by a reaction between the metal and the oxygen in the presence of water. This is a so-called redox, reduction-oxidation reaction. The metal, in this case iron, undergoes oxidation, meaning it loses electrons. In the elemental state, the valence of iron is 0, and in the course of this reaction, the iron atom loses 2 electrons as it combines with atmospheric oxygen. Metals in their elemental state always undergo oxidation when they react, a fact that can be understood based on their electronic structure. Energy is always released in the course of a reaction. Floating a piece of sodium metal on water provides a vivid example. The sodium undergoes oxidation, releasing a great deal of energy, which melts the sodium metal. In our present experiment, we use magnesium, which readily undergoes an oxidation reaction. When it undergoes oxidation, a large amount of energy is released, which may be utilized in many ways, including operating various devices. The energy released in the reaction of magnesium is utilized here to operate an electric motor. Chemical energy is converted into electrical energy, which finally turns into mechanical energy and drives a propeller. Let us analyze what occurs here. We have a redox reaction. A half reaction of oxidation takes place on the magnesium electrode, whereby the metal atoms become ions, releasing electrons that accumulate on the magnesium ribbon. The electrons produced at the magnesium electrode flow in the electric circuit through the motor toward the copper electrode. As a result, the motor is activated, and we see the turning propeller. Electrons are being consumed at the copper electrode, generating a reduction reaction. The solution in which these reactions take place consists of hydrochloric acid, which contributes a hydrogen ion to the reduction reaction, and a salt, which improves the electric conductivity and thus assists in closing the electric circuit. This device is an example of an electrolytic cell. An electric current passes through a solution of sufficient conductivity to close the circuit between the magnesium and copper electrodes on which the reactions take place. A variable that we can measure in the course of the experiment is the quantity of energy released. Even if we only immerse a very small part of the electrodes in the solution, the propeller will start rotating immediately. As the area of the magnesium electrode immersed in the solution increases, the rate of propeller rotation speeded up since a larger quantity of metal participates in the reaction, and this in turn releases more electrons. Electrolytic processes such as this have a variety of uses. One of them is the battery, or the voltaic cell. All batteries operate in this way to form electric energy that we use in various devices. In other words, batteries are containers in which chemical reactions take place that generate an electric current. An important application in everyday life is the storage battery installed in every automobile. This battery contains a liquid and electrodes between which reversible electrochemical reactions occur, enabling the system to be charged with the energy required to start the car engine. We use other types of batteries in many other instruments and devices, such as toys and watches. These are known as dry batteries, since they contain no liquid. The materials used in dry batteries react until the original material is exhausted, and then the battery is disposed of. However, today we also have rechargeable nickel-cadmium batteries. The reaction in this type of battery is reversible, which means the battery can be recharged by passing a current through it, thus supplying it with electric energy. The chemical phenomena of activating the propeller is applied whenever we start the car or turn on a battery-operated device. We have now carried out an experiment that proves to us the importance of metals in generating chemical energy and its connections with basic concepts of natural science. Redox reactions, exothermic reactions, metals, electric circuits, voltaic cells, energy conversion. One should pay close attention to the processes involved in the experiments and try to relate them to the theoretical concepts taught in class.